wait for it then. Okay, started. So this chapter 2, this slide and is prepared by IR Muhammad Sofi Momano, which is the founder for this course, as I said before, but he is not teaching this semester, and he is now teaching the IDP. So when you're taking IDP, you must face him. Okay, so project procedure. Okay, so construction project is an outcome of collaborative venture involving several stakeholders such as, okay, first clients and building owner. First, you must have clients lah. If you don't have clients, then you build the building for what, right? Okay, so client will hire a consultant. So consultants are involving architectures, land surveyors, civil structural engineers, mechanical and electrical engineers, quantity surveyors. You are from the X diploma, so I believe you already know this. No, X diploma. Are you guys X diploma? No. Oh, sorry. I'm confusing with another subject. Okay. And consultant will design, okay, design the. Can you guys see my webcam?
Blur, Doctor, blur.
Blur. I off it because at my screen is like blinking.
The screen is blinking, Doctor.
Huh?
It's blinking.
Oh, it's in the Unify makan duit bulan-bulan tapi sekarang buat ya.
But sometimes it's okay. It's like
okay,
few times.
Yeah lah, that's why. Ini bukan bulan hantu lagi. Why? I'm making joke Okay, so client will hire a consultant. Okay, so consultant will design the project, the building for the clients, and then it will involve architect, land surveyor, civil and structural engineers, mechanical and electrical engineers, and quantity surveyors. I believe you all know these 5 parties. What is the task, right? The involving architecture will design the buildings and then prepare the architecture drawings. Land surveyor will study the land conditions, okay, and then plot the layout and so on, the things. Structural and civil and structural engineer will design. I will turn off my webcam. Okay. They were not blinking. So if anything, you guys can tell me. If you cannot hear me, I'm still talking. Okay. So mechanical engineer will design for the electric part and the mechanical part. And then quantity surveyor will count and prepare the BQ And then contractor will either tender, okay, or any through the process, okay. And then they will construct the building by the contractor. So once you finish the degree, and then you can choose either you want to work in the consultant firm or either contractor firm. So if you are interested in design buildings, then you can go to the consultant firm. And you want to get IR, you need to go to consultant firm. And if you want to construct the building according to the design from the consultant, you want to experience the real constructions. Okay, you want to be the contractor maybe one day. Okay, class 1 to 7, CIDB 1, G1 to G7, you can be the contractor also. Okay, so this is the parties involved for a project So the project procedure, okay, an architect and engineer both participate in design and building structure, whether it is a house or a skyscraper. So architect and engineer both need to design, but architect design the appearance, okay, and then engineer we will take the drawing from the architect to design the structures, okay, how much the concrete want to use, what is the strength, okay, the steel inside, the diameter, okay, and the amount. So an architecture design and draw out the plans for buildings, bridges, and other structures. The goals of architect design is to satisfy the customer requirements, making the appearance of the structure of the customer liking and performing quality work. Normally architecture, they will draw very fancy, very nice one, especially those fancy building and modern buildings. And they will dump the hectic problem to us, the structure and civil and structural engineers, to design for the structure. So our responsibility will be applying the architect design and carry it through the construction. Okay, we need to build it. Okay. So the goal of this engineer is to satisfy the customer requirements and make the design functional and safely to be used lah. Okay, so customer is the boss lah. So let's say they don't want a column in the middle, but we put it, cannot. The customer don't want. So we need to find a way out, okay, to make the building safe and functionable. Okay, so other engineers that may be involved in the building design are electrical engineer for the lighting system, okay, and then mechanical engineer for the elevator, plumbing engineers for the plumbing system, among others. So there are many parties involved, okay. The key difference between an architect and engineer is that the architect focus on the artistry and design of the building, while the engineers focus more on the technical and structural side. So this is a different. The drawing also different. Okay. So the architecture drawing that you need to look for your project is architecture drawings. And then you need to convert the drawing to the technical and structural side drawing. So while the architect is concerned to make the building aesthetically pleasing, and engineer make sure the building is functional and safe. So we are playing the different responsibility lah. And normally, if in the site meeting, both parties will have fight to each other lah. Okay. So to develop and present their designs, both architect and engineer use technical drawings called blueprints. Okay. A blueprint is the detailed drawing presented by an architect or engineers that outline their design. I turn on the aircon mode. Okay. So in designing any structure, an architect has a plan out his or her ideas by making a scaled drawing. Means the drawing is being scaled lah. I believe you already learned AutoCAD, and some of you are from the X diploma, so you know what is the scaled drawing lah. So before an engineer can approve an architect designs, they have to analyze the design and select materials that can safely upon the structure. Okay, so for this subject, we are going to design the beam, RC beam, up to beam. So for column and others, so you need to learn it in next subject, which is the structural design, the reinforced concrete, I think, reinforced concrete design. And we are going to learn also for the timber and steel design for the beam and column. So this is the scope for this subject up to this point only. Okay. And then before an engineer can put the engineer take the blueprints presented by an architect and determines whether or not it is possible to build and what is the best material to use. The best material, like you need to be economic, okay, and it's suitable. The different materials have different advantages such as greater strength or greater flexibility. Okay, so there are a lot of decisions that go into every minor details of designing and building structures. A lot of decision. Okay, so you yourself, you are the engineer, so you need to make your own decision. What is the things that you need to put in the design and so on. Say no one is going to guide you, so you are the one that going to design. Okay, so in order to design safe structure that will last for many decades, engineers must stay current on the properties material, know the design flows, and research new engineering technologies. So now there are a lot of new technologies like the precast, okay, the integrated design project, and so on. Many new technologies. So we need to keep explore ourselves and update ourselves with the materials, design flows that we have. Okay, and the design procedure. So typical a construction project involve 3 phases as follows. Okay, so first you have planning phase, second you have design phase, and third you have construction phase. So planning phase normally carried out by an architect to determine the arrangement and layout of the building to meet the client's requirements with regards to aesthetic, environment, and economic considerations. So first is by the architect to discuss with the clients. And then the design phase. Okay, so once the building form and layout have been approved, so detail of the project has to be worked by various consultants. So like just now I have shown you the consultants that involving many parties. Okay, so once it's done, so the plans and design conceived on papers are translated into reality. So From the drawing, the construction, the contractor will do the constructions. So it will be translated in the reality, mean they construct it and become a real building. So a structure which may be well planned and well designed has to be well built, and the responsibility for this not only lies within the contractor, it is entrusted with the execution, but also with the construction engineers which undertake the supervisions. So who want to be the construction engineers? You need to undertake the supervision on behalf of the consultant. Okay, so in a construction site, normally the consultant will also send their engineers, okay, to observe and inspect the quality of the work to make sure the building is being constructed accordingly and then according to the standard with the safety, everything lah. So task of a structural engineer. So for a structural engineer, okay, we have 5 tasks here. Yeah, 5 tasks here. So first, select the most appropriate structural system and idealize of the building into frames and elements. Okay, so you need to select the properties, select the materials, select the structural system, okay, and idealize it. And then second, we need to estimate of loading. So of course, we need to calculate the loading for the design building before we start design the beam and so on. So this is by next week, chapter 3, we are going to enter this estimation of loadings. And then analysis is to determine the maximum. And next week is cuti, right? I baru ingat. Yeah, next week we have another cuti. So it's another awal Muharram. Puasa tak?
Ramadan.
You guys fasting or not? I'm not fasting. You guys fasting.
I think that's the
Awal Muharram bukan awal Muharram.
You guys some are not in Johor, is it? Sampai lupa puasa.
puasa ingat, cuti tak ingat.
Is
Puasa ingat, cuti tak ingat.
Johor cuti ya. So tak apa, I dah setkan, I tekan bagi take home quiz next week. So you have next week you need to do a quiz. So I will brief to you by end of this week lah. Okay. So estimation of loading, we need to see you on week 5. Week 5, we will go to chapter 3 lah. Next week you are going to do a quiz. Okay. Sempat lagi, that's why I didn't have any replacements class for you guys first. We will try to finish the on schedule lah. Okay. So this is in the chapter 3. We are going to estimate the loading from the GK and QK. Okay, so this ignore it first. Not going to do it today. So analysis to determine the maximum member force like moment, shear force, torsions. Okay, and then design of sections, reinforcement arrangement for all structural elements, production of layout and detailed drawing and bar schedule. So this is basically how you're going to do prepare a structural drawing, including the detailings and so on lah. Okay, so first, once you get the architecture drawing, you need to convert it to structural drawing. So after you convert the structural drawings, okay, you already design and estimate the beam size, the slab size, the column size. Then you need to start calculate the loading. Loading including the dead load, the live load, the service, the finishes, and so on. So after you calculate the loading, then you can start design the slab, the beam, the column, the staircase, and so on. So for this subject, we only cover beam. So at here, the part of this is analysis, the beam members like moments, shears, torsions. This one you need to calculate using the moment redistribution. Kamal is just enter. Oh, you guys also sign in and out. So moment, shear, and torsion for the maximum bending moment and shear force, you are going to draw the shear force and bending moments for the simply supported beam. You calculate as usual. Okay. And then for the continuous beam, you need to use the modified moment distribution method that you learn from the structural analysis. Okay, that one I will not go through deeply because you already learned before. And to go through that, it takes around 1 week to do it. Okay, but I will briefly explain, and then I prepare a YouTube for that. So design of sections, reinforcement, arrangement, this one is also in chapter 4. You're going to study in chapter 4. Production of layout and detailed drawing and bar schedule, this is also in chapter 4. So basically this part 3, 4, 5 is in chapter 4 and part 2 is in chapter 3. And for your test 1, that is only until chapter 3, loading estimation. Okay. So for architecture drawings, okay, architecture drawings are an essential part of any design and building projects. They are type of communications, translating the ideas of clients or designer into collection of drawings. Okay, so it is clearly accurate to lay out what to be built and where it is to be built and how it is to be built. Okay, so we need to, once we look at the plans, we need to imagine the building, how does it look like? Okay, so they provide information and specification to not only the clients, but any additional consultants required on the project. So normally the architecture drawings consist of site plan, floor plan, roof plan, and elevations. Elevation is the plan that we cut through, like X or Y decisions, okay? And elevation is the front, rear, and side, and section is the cut section, the cross section, sorry. Okay, so we will go through one by one the example. So first, what is the site plan? Okay, the site plans, okay. If you already been through diploma, then you know what is this lah, especially if you are LI in the internship.
Doktor, mic doktor berbunyi.
Berbunyi lagi. Yang macam ni pun pakai yang laptop je lah, dengar tak? Suara dia kurang kuat sikit
Dengar je.
Dengar je tapi kurang kuat Okey.
Dengar.
Dengar kalau tak I kena jerit kuat sikit, macam jerit-jerit dalam kelas gitu. I need to if you like, I need to shout even louder. Wait, let me drink. Okay. So a site plan. Okay, architecture will start the drawing by preparing the site plan, which is a view looking down at a building from above. So site plan is from above, From above, you're looking down at the building form. So the plan was created to illustrate the location and orientation on a block plan. It is provided information about the site topography, okay, landscape, utilities, site work, and it is also very important for architect to make a site plan to illustrate the existing nature and build features. So site plan is clearly for us to see. Okay. So you can see this is a site plan. From first, you can see the key plans. Okay. So this is example key plan. So you can see that where it is the proposed site. So it will tell you this is a building that is at here in the Batu Pahat. Okay. So location plan. So this is at Jalan Keluang Batu Pahat. Let me zoom more. Okay, so it will illustrate where is it located. Okay. So, it's too big. So the location plan will show you is it here. Okay, at here. Okay, after that it will zoom out, zoom in more. So this is the view from top. Okay, from the top of the building. So this is the site. So it will show you the nature, the topography. So this is the site plans. Let me zoom it out back. I'm not using PDF to view it now because PDF now cannot have this function for draw, for many things cannot. So basically this is a drawings, okay, for a site plan. Okay. So you already learned AutoCAD before, I believe you know this friends. So this is the, again, you can see the location plan, the key plan, the locality plan. Let me zoom in more. Okay, you have the PDF slide also, you can zoom in more if you want to study it more. So you can see that. So from the side plan, you can see legends, the bomba, and then it will have you the explanation. What is this building for? The base, where is the client, and so on. Okay, the key plans, where is the proposed buildings from the top view. Okay, the locality view, where is it? And then it will give you the view for its surrounding and where is the proposed building. So this is the proposed building from the top, and then the existing building, the existing classroom block, the toilet, the existing, all the existing they were mentioned. So this is the new proposed building. Okay, so this is the example site plans lah. Okay, and then next we go to next slide. No questions, right? It's easy, right? Just introduce to you what is the plan. Belum lagi, when you face the architecture plan, then you will have questions. So a floor plan is the most fundamental architecture diagrams, a view from above showing the arrangement of spaces in the buildings, the same way as a map, but showing the arrangement at particular level of a building. So floor plan, it will according to the floor. Okay, so if you have, let's say you have a single story building, then you will have ground floor and roof floor. Okay, but then if you have a double story building, then you will have ground floor plan, first floor plan, and roof floor plan. Okay, so technically it's a horizontal sections cut through a building. So means the building you cut through horizontal according to floor. So you cut, okay, in between roof and the ground, so it's become ground floor. Let's say single building, and then you cut at roof, then you will become a roof floor. So it is actually a horizontal sections showing the walls, window, doors open, and other features. For architecture plans, it will show you where is the door, the windows, the walls. But then for structural plans, no. So we need to convert all this into a structural plan. So the plans view includes anything that could be seen below that level, the floor, the stairs, but only up to the plan level if for the stairs, fitting, and sometimes furniture. Okay, so if you, let's say you download some, you get the brochure that people selling house, especially like the single story house, the double story house. So they will even put in the furniture, like the bedroom, they will draw the bed, and they will draw the wardrobe and so on. Okay, so geometrically, plans view is defined as a vertical orthographic projection of an object on a horizontal plane with the horizontal plane cutting through the building. Okay, so this is example of 3-story kindergarten buildings, I think this one. Okay, so you can see this is example buildings. Okay, so you can see that they will have, let me zoom in more. So this is not a structural drawing yet. Okay, it will mention and explain to you. You see this is the door opening. Okay, so this is what area? Dining area. So this is meeting room area. So this is the corridor, the staircase, okay, the stair, the office, the nursery, 1, 2, 3, 4. And then they have toilets. Okay, toilets also they will have drop. They will explain drop how much. Here, the drawing is very detailed and I cannot see. Okay, so you can see these buildings, the toilets here. Normally toilet will have drop lah. So where is the up, where is the drop, they will show you. Okay. Drop means is lower than the normal slab. Because when you go to the toilet, normally it will become lower. You will drop the slab, right? That's what we mean drop. So when you design also, you need to drop the slab. Else the water will go to other places lah. Okay, so if you don't believe me, you go to toilet later, not now. Okay, so this is the corridor and so on. But you can see that this is all the doors. Okay, they will include all the details, like mention utility rooms, where is this, where is that, for all the information. And then they will show you, you see this They will show you Y1 and Y2. This is where they will prepare the section, the cut later for you to see. Okay, and then they will have X1, Y1, and then they have the direction. You see, this is the arrow direction. That means that it is later the view provided by X1 is C from this to there. Okay, going to here. Okay, from Y1 means from here to here. Ah, yeah, my mouse is not nice at drawing this. I need to use the tablet, but I'm lazy to take it out. Okay, so it's from here to here. Y2 also same. Okay, so you need to see the drawings, not only one, but you need to referring the drawing from each one. So when you have the plan also, you will have plan, the elevation plan, you have A, B, B is from here. Okay, C and D. So we will go to more. Okay, so this is the first floor plan. So that one is ground floor. So now it's first floor. So first floor, you can see, you can compare what is the things that they have or what is the thing that they don't have. So ground floor, they will not have the corridor just now, right? The corridor, they don't have any wall. But then here you see they have the wall design and so on. Okay, this is a wall that they have to build. They have the corridor they build. It become like cantilever structure. So you can see that here don't have anything column. No column, right? Corridor, you can see here is nothing. You get nothing here. Nothing here. Okay, but then you can see where come here, you can see here you have the columns and so you have the point. No columns in. You have the wall. Okay. So this is the first floor. Also second floor similar, but it will show you what is the purpose for this room. So it will show you the purpose of the room is also important. So for you to calculate the loading. Okay, so different area they might have different loadings. Like for the corridor, you don't need to use you can use secondary beam instead of the primary beams because the loading is small. It's just the human traffic. Okay, the staircase, the toilets, where is the location for all this? This is architecture drawing. So the roof floor. The roof floor will show you where is the floor. Means the RC flat roof with a Sika waterproofing, the details. This is the roof. They will show you what is the requirements they want. Okay, this is the light beige color, clean color, bond thickness 0.4 at TCA at pitch bubble foil on hot tip, galvanized iron frame to structural engineering details. So you want to read through this detail one by one, you can go through it. Okay, it will show you like what is the detail of this. Okay, RC flat roof, okay, the waterproofing, spoon drain and so on. So this is the roof. So they will give you the details. So this is the roof that they have to use, the frame, the iron frame, so on. So the directions. Okay. So that one is architecture plans. So this is become the ground floor plan. Wait, let me show you the elevation that they have it. No, this is another building. Okay. This is just now I think this is the same building. Alright, I go to the ground floor drawing first. Wait, let me go to that. Okay, so if you have this PDF, if you already print it out, you can see the plans. But then this is another building. So for this is actually from a book last time sold by the Mr. Sophie, Practical Design Reinforced Concrete Building, if you can see my webcam. So this is another building. Just now is the nursery building, but this is a 2-story school building. Okay, design for it. So it's a book from UTM from Muhammad Saleh Yassin. Is very famous lecturer from UTM. Okay, so this is another buildings, another buildings, another drawings, another set of architecture drawing. Just now the first example, this one is for nursery, the kindergarten. So now we have another set of architecture drawing. Not same, different drawings, different set. So you can see now is another drawing of a school building. I zoom in, zoom out more to let you see the overall. Okay, so this is a ground floor plan for that drawing. So you will have a simple building like this, ground floor, okay, classroom 1, 2, 3, 4, all these are classroom, toilet. So this is the toilet area. Imagine when you are in the school, the toilet is always at the end of the building. And then this is the library. Okay, so all these are corridor. Okay, corridor for walk, halfway, and then this is the staircase to go to the second floor. So when we look at the floor, we need to imagine the buildings also. Okay. So this is the first floor plan. The first floor plan, when you climb the staircase, so you can see here you got one staircase, here you got one staircase. Okay. So going up, okay, when you're going up, so this is the continue the staircase here, you're going up. So this is another, this is at the top. Okay. So the building, the classroom, this is the office. So just now the ground floor is the classroom. So at top here is the office area, and this is for the workshop, and this is still the toilet area, and this is all the corridor. Okay, so you can see that the corridor, they didn't put the columns, means they design as the cantilever beams. The cantilever, the load we're going to distribute to the column here, the main buildings. You can see here they got designed the column, right? But then at the corridor there is no column. Okay, here also no columns. Means this is not to the ground. It's just cantilever supported here. You will distribute the load to here. Okay, so this is first floor plan, and second floor. Second floor plans is okay. So this is again classroom, and toilet, and here is workshop. Different from the first floor plan. The first floor plan here is the toilet area. So the doors like this, and then here they got no brick wall, no wall, because the office is in the school normally is open. Okay, so the toilet also, how many toilets you have, and then they will have the details. Okay, second floor, and then this is the roof floor. So from this you can imagine how the slope of it, the fall look like. So the top point, the highest point will be from here, and then it will fall from these directions and to these directions. Okay, you can see from this. Okay, so this is the 4 directions. Okay, and here is the 4 directions, and this is the column. So they will show you also where is the column direction basically. Okay, for the main column like the architecture design. But you also, if you needed any columns add on, you can add on also. Okay, but then the beams here not necessary to be the beam that you only can put in, like basically the beam normally will follow the locations, like you know if the plane like this, so basically the beam will be like follow the shape of the building, but then you need to add the beam that is needed, and then it is like flash, like in a slab, the French beam. Okay, join with the slab, become the T French beam or the L at the corner. So after you get that, all this plan, so that one is finished, that plan, the floor plan. So we go to elevations. That just now is 2 examples of the ground floor plans. Don't be dizzy with it. So elevation is a view of building seen from one side, from the side view. Just now is the floor view. Okay, from top you cut section horizontally. So this is elevation from the side. Okay, it's a view from a building seen from one side, a flat representation of one facade. The most common views used to describe the external appearance. Okay, is to describe the external appearance. How does it really want to look like after the completion? So each elevation is labeled in relation to the compass direction it faced. Just now I mentioned the view from A, B, C, D according to that drawing, right? So you have a compass directions. So from left, okay, the view is from here. Okay, from right, from left view to the right and right to the left. So you need to put the compass directions. Okay, looking towards the north if you're seeing the sub elevations of the building. So buildings are really a simple rectangular shape in plan. So a typical elevation map shows all the parts of the building that are seen from a particular directions. Geometrically, an elevation is a horizontal orthographic projection of a building on a vertical plane. Okay, the vertical plane normally being parallel to one side of the building. Is parallel to one side of the building. Okay, so examples. This is the elevation for the school building from the front. Okay, from the front here you can see ground floor, first floor, second floor, and the top, the roof floor. So actually this is the plan for this building. Okay, you can see this is the first view, the building here. So the view, it should be here, but then it is not 3D. So the building is basically L shape. You can see it is L shape, right? The L gun. But then if you view from here, if you view from here, if I slot in this one, if you view from here, oh, the internet is, wait up. If you view from here, from here, okay, this and this is going to, it will not show this part. This part is not being shown. Okay, it will show the view from here to here. Okay, from here to here. This part. That's why when you see the building, okay, you can see this part, the school building, and then until here. Here is actually that part. Okay, but it's being overlapped because it's not 3D. It's view from the front view, and then you have the back view. Now, from the real view, you will see from the rear, which is this side. Let me go back to this. If mentioned the rear view means it's from this side. So you will see, you will not seeing this part, but you will see all this part. You will see all from here to here. Okay, so this is the rear view. And this is the front view. Go back, you want to, if you are not familiar with the architecture drawing, after this class, you can go through the slide again, you imagine and you compare, because you yourself, you have to do the project, okay? So this is the real view. From real view, what does it look like? You can see that this is the corridor, and then the school building. I believe everyone got in the school before, so you are very easy to imagine the school building, okay? Ground floor and then upper floor. First floor, second floor, and roof floor. Okay, so you can see each building, how does it will look like when it is complete. Okay, so you need to have the imagination, how does it look like? Because if you are work in the contractor, become the the engineers, site engineers, then you need to construct to make the building look like this after it complete. Okay, and then view from the right side and from the real side. This is from the right side, which is from this side. Okay, from the right side, and this is from the left side. How does it look like? Okay, so you can go through it again. And then the front elevation is not my parcel, some other my neighbor's parcel, PPP, if you can hear it. Okay, the front elevations. Okay, so this is the left elevations. Okay, and then this is the real elevations. I think this is for the another building. This is the right elevations. You can go through it. So if you have this book, it will show you the elevations. Oh, this is for the This is for the, sorry, just now this one is for the kindergarten buildings, and the kindergarten building, the 3-story. And this is for the school building. Okay, for the school building. My cam is error again. Switch it off. Okay, so this is for the school building. The front view, left elevations, rear elevations, and right elevations. Okay, so just now this one, the A, B, C, D view supposedly is for, I need to scroll to the top. These two buildings is looking similar. Wait, this is the A, B, C, D view. Okay, my internet is not working okay today. It's delayed again. Wait. Wait, my computer is protest now. It's hanging. Hiya, wait, why is it hanging? Never mind. I opened it. Wait, my computer is hanging. The screen is not moving. Let me open this one, but this one I cannot touch it. Okay, so just now you have 2 sets of it. You can go through it. Okay, the right view. Okay, the cross sections. Just now we already explained the elevation plan, so now we go to the cross section plan. Cross section plane is also simply called a section represent vertical plane cut through the object, and everything cut by the section plane is shown in a bold line, which are solid fields to show objects that are cut through, and anything since beyond general shows in a thinner line. So used to describe the relationship between different levels of building. Combination of cross sections with elevations of other parts of the building seen beyond the section planes. So geometrically, the section planes is a horizontal orthographic. Okay, so you can see that this is they cut through the nursery at the kindergarten. Okay, so they cut it, and then you can see that this is the cross sections. Just now we have the front view, the side, the elevation view from outside, exterior only. So this one will cut through the middle, so you can see that from x1. So when you cut, and then according to the view, what you will look at. So you can see that this is the ground floor, first floor, and ground floor, first floor, second floor. So you will have the area of prayer rooms, computer room, library, classroom. Okay, and then this is the corridor. Toilets is here, I think. Okay. So XX, and then the YY, when you cut from that view, it will show you the staircase. So this is the design of the staircase. So you climb, and then this is, okay, the stair, and then you're going up again. So this is the design for it. So you can see all the details. You have the PDF, you can go through it again. Okay, so we'll cut from Y2 and Y2. So you will see the views like this. Okay, the corridor, how does it look like? Okay, the frame for the roof. Okay, roof truss, how does it look like when you want to calculate the loading? Okay, so this is Y3. The toilet, how does it look like? You need to build exactly like what the design want. Okay, so this is the XX. for the school building. Just now is a nursery kindergarten building. I confused with these two already. Okay, so this is the XX for the school building. They cut the XX sections, the YY sections for the classroom and office. Okay, and then they cut again. Just now two examples only. Okay, so that one is example architecture drawing. So basically you have site plans, the floor plans, the elevation plans, and cut section plans. You have 4 types of plans for the architecture plans. And then engineering drawing is a plans or set of plans for how a building or other structure will be built, generally prepared by structural engineers after getting an architecture plans for the building. So this involves determination of the following. So what you have to do, okay, we have to determine the position and orientation of columns, positioning of beams, spanning of slab. You want it to become one-way slab, two-way slab. How small, how big you want it to be look like. If it's too big, too wide, it will have failure, the failure at deflections. Okay, and then the layout of stairs, and then selecting the proper type of floating that's suitable. Preliminary concerned with the load carrying members of a structures and consists of structural elements, size and type of materials to be used, as well as the general demands of connections. So communicate the design of the structure to authorize to review and approval. So then you need to draw out the plans and then to get the authority to review and get approval. And then part of the contract documents which guide contractor in detailing, fabricating, and installing the part of the structure. So you need to provide the details, the detailings, so they can do the fabrication and installing part. Following it, I want to see that it is already not hanging. Let me check. It's still hanging, Okay, so positioning and orientation of columns. So when you do the when you design for the column, first step, before you go for the calculations, okay, there are some of the building principles which help in deciding the column positions. Okay, columns should be preferable. Okay, later we'll have the drawings. Okay, should be preferably located O and at near the corners. So normally it's at the corners of a building and it's at the intersection of beam, of walls of beam. So let's say you have an intersection like T, or either the cross, okay? So that location, normally we will put the column because the load will be being distributed to the corners of a building and to the intersections of beam and walls. So at there you should put columns, okay? So select the positions of columns so as to reduce bending moment in beam. Okay, you need to select the position. It cannot be too far, so else the bending moment will be big. Okay, and then avoid larger span of beam. So the beams also don't make it too, the span don't be too wide. If too big, then you will have bending issue. Okay, deflections. Avoid larger center to center distance between columns. So this is both the same lah. If you have larger span, mean that your column is far from each other. So we need to avoid that. So column need to be on a property line. Okay, don't get out from the property. It must be in the line with the property. You need to flash it in. Okay. So if you normally, if you already become the consultant engineer, you will not doing this manually lah. They have the software like the one that you are going to learn in UTHM is Extreme lah, for example. Okay, there are many out there, but the basic is normally the same thing. Okay, positioner and orientation of columns. So the position of column outside the wall in the room should be avoided, as they are not only giving bad appearance but also obstruct the use of the floor, creating problem in spacing furniture flush with the wall. So column normally we are flush with the wall, means that the column you cannot put it there by itself. So it will become an obstacle, obstruct the use of the floor space. Like example, you go to the shopping mall, suddenly it will have a big column in the middle. It will obstruct the walkway. Okay, it will not giving a good appearance lah. So normally it's flush. Even if you are at your home, you will not have a a column in the middle, right? It is all flush with the wall. Okay, it's already built in together with the wall, so you are not going to see it too obvious. So the width of the column is required to be kept not less than 200 millimeter to prevent the column being slender. Slender means the column is too thin and then too long. Okay, the ratio. So it is not the width normally is not less than 200 mm at least. Okay, the spacing of the column should be considerably reduced so that the load on column for each floor is less and the necessity of last section of column does not arise. So if the spacing is bigger, then you need bigger column. So if you reduce the spacing of the column, so you can reduce the size of the column. So orient the column so that the depth of the column is contained in the major plane of bending and it is perpendicular to the major axis. Okay, so this is provided to increase the moment of inertia and hence greater moment resisting capacity. So it is depends on the the I and the BD. Okay, which number of BD you want to decide. Normally B is higher than the D, right? Okay, so this is the meaning. So you want to get the higher I, the moment inertia for the greater moment resistance capacity. So it is also reduce the span to depth ratio, resulting in increase the load carrying capacity. So the orientation of the beam is also important, and the column is important also. So positioning of beam. Following are some of the principles which help to deciding the beam positions. So beam shall normally be provided under the wall below a heavy concentrated load to avoid this load directly coming on slab. So the loading from the slab will distribute to the beam. And then the wall also will stay on top of beam. Okay, so beam will distribute load to the column and then to the foundations. That one we already learned in chapter 1, how the load being distributed from the slab to the beam to the column to the foundations. Okay, and then avoid larger spacing of deflection and cracking criteria. So the deflection for larger span. Larger the span, larger the deflections. Beams shall normally be extended as functions to support the secondary beams or to provide rectangular shape of slab. Okay. So let's say what is secondary beam? Normally dekat mana yang ada secondary beam? Can you guess? Anyone know? Ada idea tak? Secondary beam tu biasa letak kat mana? Normally at toilet
Kat toilet.
Bathroom, yes, toilet. Toilet normally if you design, you don't need to put it in the front there. The toilet already small enough. If you put the column at there, then where are you going to bath? It's too small and then it is no need. The loading is small only. So normally the beam will the secondary beam means the load from the secondary beam will distribute to the main beam. So the main beam will distribute the load to the column. Okay. Next slide. So spanning of slab. So this is deciding supporting arrangement. So ini nanti we will also from the calculation next chapter we will learn the singles, the one-way slab and two-way slab lah. So when the support are only opposition each or only in one direction, so the slab are considered as one-way support. Means it's only distribute either to one way only. Okay, to the left or to the right. This is not going to the four directions or either to the top and to the bottom. It will not to the four edges if it's the step. Okay, later we'll see the example. I think in the practice when the rectangular slab is supported along four edges, means the four edges are top, front, rear, left, and right. Okay, so it's supported along its four edges and it is one-way slab. So it is mean that Ly over Lx is greater than 2. Ly is the y directions and the x direction length of the beam. Okay, the span Ly over Lx is over 2, even though it's supported by 4 edges, but it's still considered as one-way slab. The load will not distribute to 4 edges, but only 2 edges. So in one way slab, main steel is provided along with short span only, and the load is transferred to two opposite support. Okay, two opposite support only. And two-way action of slab occur when Ly over Lx is less than 2. Less than 2 means the span of y and x is less than 2. Since the slab is also, the longer one will be y, the shorter one will be x. It is not left. The y and L and y here in the slab doesn't mean that Ly must be at the y axis and x must be the x axis. Ly is the bigger value of the slab. Slab span. Ly is the smaller one. Okay. So since the slab is also supported over the short edge, there is a tendency of the load on the slab by the side of support to get transferred to the nearest support. This is calculation is important also, so you need to calculate the right distribution of load. Okay, which is a lot of students normally make some mistake to calculate. So next chapter will cover it. So a two-way slab is generally economical compared to one-way slab because steel along both spans act as main reinforcement and transfer the load to all its support. A two-way slab is better than one-way slab lah. Okay. Go to the next. And layout of stairs. It is constructed to provide ready, easy, comfortable, and safe ascent descents. It consists of a flights of steps, usually with one or more intermediate landing. Okay, provide between the floor. So just now we can see the intermediate landing. Okay, so the landing is provided in between the steps. Okay, but in between the floor levels, you cannot directly climb up. But okay, it is not comfort design. If you keep continuously climb up, that one is hiking, I think. Okay. The dimension of stairs should be such as to give the maximum comfort to the users, which depends on the use of the buildings. Okay, the basic guideline of staircase layouts was clearly stated in uniform building bylaws. Okay, and BRIEF, blah blah blah. You can go through it, but this is not in this subject. Normally, an architect will provide all information required in designing the staircase. Normally, architecture already decide the staircase design. Okay, so you design accordingly. It's structurally designed to consist upper and lower support. Okay, so at the staircase location, do you have slab? When you want to consider it, a slab, is it considered as slab? When you calculate the loading distribution, we make it as void. When we calculate the load for the span and for the slab, we will not consider a slab. So that one will be next chapter lah. Okay, footing type. The type of footing depends upon the load carried by the column and the bearing capacity of the supporting soil. For the pit soil, then we need to have the pile. Depends on the supporting soil. So if the supporting soil is strong enough, then we just need shallow foundation. We don't need deep foundation. So the soil underneath the foundation is more susceptible to large variations. So every under one small building the soil may vary from soft clay to a hard sand. It is necessary to conduct the survey in the area for soil properties. You need to do the site investigation lah. Okay, take the ball pile and then test and then do the investigation. That one you will learn in geotechnic. Okay, for frame structure, isolated column footing are normally preferred except in case of existing great depth. High foundation can be an appropriate choice. If columns are very close spaces and bearing capacity of the soil is low, rough foundation can be an alternative solution. So for a column of boundary line, a combined footing or a rough footing may be provided. So this one you learn in foundation and geotechnic. Okay, so this is example of the footing plans. So you can see that this is the building for the school building, I think. Okay, school building. So this is the footing plans. It will show you the size of the footing, and then together with the loading it needs to support. You can see that this is like to support 900 kilonewton. The column one, they will have the detailing, but here it's not showing you the load for the 1884, the 1864, 17 something. Okay, this is all the loading they need to have. And then you can see that when the column is too near, then they will combine these two columns with one footing. And these three columns, they combine, become one footing. So this is the group of columns that combine with one footing. Okay, not necessary to have one column, one footing. If they are the location of them are too near, so you can combine it together. So the load will distribute to the same footing. Okay, so this is the ground floor plan. Just now you can see the fancy architecture plans that we refer to. So now you can see that this is the ground floor plan that structural engineers is going to do. Okay, so you design, okay, so this is the floor. Here, one lacking thing is it didn't show the slab, either is one way or two way. Okay, so you can see that this is the floor, and this is the slab, this is the column, this is the beam, toilet areas, and this is the ground floor plans. But then you can see that this is the ground floor plan, but then you can you notice that this line is straight line, solid line? Solid line means, okay, it is not the French beam. This is all the the rectangular beam. Means the floor, they are designed the floor with the non-suspended floor. Non-suspended floor is what? Non-suspended floor is that the load from the floor will directly distribute to the soil underneath. It will not distribute to the beam. So it is not French beam. So if you design the ground floor as non-suspended floor, so the beam is rectangular. If you design the floor as as suspended floor, means it is French beam. Okay, the beam and the slab is connected. Okay, it's joined together. So that's why it becomes French beam. And then this is the column. So column is this is H, black color, black in color means it is on the top is have the column still. It has the ground floor column and it is also built until connect to the next floor. So means here you have columns. Okay. My internet, that one still not okay. I want to use that better to. Oh, it's still not showing me. Wait, because I want to draw something, it's much easier. I just don't want to. Let me. Still not wanting. Okay, doesn't matter. Okay, so you can see that at the toilet area, okay, also they have drop. When you have drop, or either you are not suspended floor, so it is solid line. So you can see the difference when it is in first floor, when it is the dash line. Okay, so this is all the columns are going to the next floor. That's why it is all in the H color. Okay, it is the white color with a cross sign mean that on top of that floor there is no more column. So in this example you can see this. Okay, this is the school building. Okay, this is the school building. Now you can see. Can you see that this floor? Oh, just now that one is no this sign. This is the sign of how the load of slab being distributed. Okay, for this sign, you can see this sign. S1, can everyone see the S1, S2, S2? Can you see this?
Yeah.
Yes, doctor.
This is the direction. So for you, when you want to do the test one, quiz, tutorial, you need to, from the architecture drawing, you plot this drawing, but it is not this complicated lah. Okay? Tak sepanjang ni, it is not as detailed as this. So you can see that this is the dash line here, means that this beam and the floor slab is connected. It's suspended slab. Okay? But then you can see that the slab here and here is not, because at the column, at the corridor normally is lower than it is suspended, but it is having the drop. It is lower than the floor, the beam, so it has a drop. That's why it is the solid line. I zoom in a bit. Wait. Okay, so you can see that this is all the slab that having the dash line, means it's suspended. Okay, and then you can see that the toilet is suspended, but then you have a drop. So you can see that from the drop point is using the solid line. And then here is also have another drop, so there is solid line. But then these all beam and the slab, they have no drop. That's why it's using the dash line. Okay, so you can see here is solid line, means that the corridor here is having the drop. Okay, so this is the line for the beam when you draw the structural drawings. And then this is the mark that where is the load distributed. As I said, this is a, if you see the architecture drawing just now, here then don't have beam, right? But in the structural drawing, if you feel the span is too big, you can add the beam. That's why sometimes when you see the buildings, even the house, when it is not being covered by the plaster ceiling or cornice, you can see a beam across. That's why they put a beam here, across. If you from the rooftop and the ground floor, you look at the beam on the ceiling. They have a slab and they have a beam sometime, right? Other right, some building they have the slab, the beam. Can you imagine? Other kan? Can you see before the beam, the French beam in the middle sometime? I want to take photo and show me next time in the Telegram group. Can you imagine that? The T-beam? Anyone? Okay, so this is the beam they add on in between the slab. But then they have no columns. No columns here. Means the load from here will distribute. Okay, the load here will distribute to the left and to the right. And here will to the left and to the right. So from this is the secondary beam. This is what we call the secondary beam. So you can see this beam, secondary beam, is going to distribute the load to this main beam. Secondary beam will distribute load here as the point load. Okay, here you will have a point load to this beam. Consider this one once you calculate the load from the secondary beam. The secondary beam load will distribute to the left and to here and to here. So you will take half. Okay, so from here you will distribute to this column and that column. So this is secondary beam. This is secondary beam, this is secondary beam, and this is secondary beam, where there is no column supported here. Okay, so this is all secondary beam because you see there is no column provided. So it will go through the main beam, and then main beam will distribute the load to the column. Okay, so this is first floor. Wait, I zoom out a bit. So this is second floor, similar, and this is roof floor. Okay, just now this one you see. Okay, so I forgot to explain the staircase area. It's blur. Sini blur. You can see that when you calculate the floor, here is the straight line. Means that when you calculate the slab distribution, the load is not distribute from the staircase to this beam. Staircase is going down, right? So this beam is not taking the load from here. Okay? So it's considered the void area. So when you go to next one, this is the roof plan. When you consider the roof plan, you can see that now you can see the column is no longer in the black color, right? Just now the floor before, the column, you can see the previous one. All the column are in this one, in H, right? Black in color. And you can see here D column D5. When you go to the next one, column D5, now is in this. Okay? Cross. white color, no color with cross. So you can see this is a roof plan. Let me zoom in for you to see. So it's a cross, actually there is a cross inside. Have a cross here, X signs. Okay, means the column stop at that floor and not going to on top again. On top of this floor, no slab. And no more column. Okay, so the column ends at here. So can you imagine when the ground floor, there's a column here and then there's a column on top. So first floor also column on top when it is black color. And then until roof floor, so the column is only until the roof. There's no more floor on top. Okay, so that's why it is in this color, no color, sorry, it is called cross, C-R-O-S-S. In black color is called H. Okay, so the black color means the H1 means the on top of it still have column. When it is putting the cross signs means the column stop at there. Okay, so the column stop at here, or the column stop at this floor. And then this big cross signs mean that there is no roof, there is no slab. So at roof here, only you have 1, 2, 3, 4, 5, 6 slabs here. Other are no slab. Okay, it is just the roof frame, the roof truss. Okay. So this is what basically you have to prepare. So this is the truss layout. Okay, you can see that this is a truss layout. Normally rooftop will have no slab unless they have like the place to put the water tank. Okay, so normally I expect this place is for the water tank and so on lah. Okay, something you have to put the slab here, and then all these are just rooftop. This is the solid slab here. Okay, but then they have the rooftop here. So truss layout, you don't need to prepare for this. So preliminary element size, I'm not going to touch it today. It's just 2 pages, and there's a preliminary beam size. Actually, I already prepared the video, but I'm going to expand it next week. So actually now I want you to look at this one. This one is from last semester. Okay, last semester questions. Actually, this is last semester questions from the final exam. Let me open the questions for you to take a look. You want to take a look the final exam question last semester? Do you want?
Boleh juga.
There's no one.
Boleh.
Kalau you reject, you pelik lah kan. You must take a look, right? Kalau I pun I take a look. Okay, so this subject, you can see that this is the final examinations online. Okay, last semester is online and this semester is still online. 2.5 hours for you to answer, another additional 30 minutes for you to upload the answer sheet. So totally 3 hours. But actually 2 hours and 30 minutes you need to done everything, and then the last 30 minutes is for you to upload. Also same as your test later. Your test will be, I think, 1 hour and a half or 1 hour, I cannot remember, and then you have extra 30 minutes to upload. And for this semester, we all are compulsory to use Author for test and final uploads. Okay, so it's open book examinations. It's open book. That's why I asked you to buy the Eurocode, so you can open book anything. Okay, design should be based on this. They gave you the standard. So normally they will have questions, explain the theories for chapter 1 from chapter 1 and 2, and then they will show you figure 1 shows something, and then this is also theory. So figure Q1B show an architecture first floor layout plan of a reinforced concrete bungalow house. So you need to read now. This is the important things. So a first floor. Okay, as a structural designer at the consultant engineer firm, you are required to perform the following tasks. So first, propose a structural layout plan that consists all elements that need to be designed in this project, considering the first floor plan only. So once you read this, you go to the question QB, which is this one. Is it same as the one that I showed you? Yeah, so I already give you example today. So this is the example from the past year final. So once you do this, you get 8 marks. Later I show you the answer scheme. Okay, so what next is, mana pergi? Okay, so this is the first part, and then you do this is only give you 8 marks from 100 marks. Okay, after that, you need to calculate the characteristic actions subjected to beam 2AB using the following data. So you use this beam size, slab thickness, brick wall thickness, height, weight, concrete unit weight, floor finishing and services. You need to calculate the actions that are acting on a beam, beam 2AB. Beam 2AB here is mean beam 2A to B. This beam they want you to calculate. So how you propose the beam? How you propose the beam locations, slab locations, it will affect the loadings. So you must make sure you have the idea on how to calculate it and how you estimate where you locate the beam, locate the slab, and so on. Okay. So like this, you can combine of chapter 1, 2, and 3. Then you can answer question 1 in the final. Normally the something like this. Okay, so another they will give you the theory again, but not every semester like this. Our question 2, they will ask you to do the design of chapter 4. Chapter 4, which is the beam design. A rectangular beams is and then yeah, question 2 is for chapter 4. Question 3 is for timber. Basically, normally questions. Okay. So I don't want to go to other questions because now we are only at the chapter 2. So let's get back to this, and I want to show you what is how you get that structural plans done. Let me find the answer. Okay, so what is the content you need to have? So this is the content you need to have. You better write down. This one I will not give you. Or you can do whatever you want. This is the marks that you will get checked from your architecture plans. Okay. So let us take 5, and then while I show you this, I open like this then you can see. Zoom smaller. No. Later. You write down this first. Okay? You write down what is the things needed first. And you look at this plan, this architecture drawing first. Can everyone see this? You can see this, right? You think first how you're going to do. Later I will explain to you. We take 5 minutes rest. Is it okay? Okay.
Okay,
I say okay.
Okay, doctor.
I want to have a toilet run. Bye bye. 5 minutes, Nanti. Don't go anywhere. You look at this. Bye bye.
Doktor kat mana doktor? Kan aku seorang tak dengar di bar. Kau dengar tak?
Tak weh. Break
Tak
time,
dengar,
break.
tak dengar.
Break. Take 5.
Doktor ni. Okay.
Can you hear me? Boleh dengar tak?
Boleh dengar.
Boleh doktor.
Tak ada. Ini saya sambung balik mic ni. Saya punya mic laptop pula tak nak working. Kenapa tak? Pelik lah. I kena beli laptop baru ni. Petang ni ada kelas lagi. Ini saya dah upload dekat Google Classroom belum ini? Belum Yang ini belum kan?
Doktor upload yang tutorial saja.
Ini belum You guys nak benda ni yang ada architecture dia dengan structural ni? Mestilah nak kan?
Kan doktor? Nak tengok.
Doktor.
I will give you, don't worry. Sebab I rasa it is good for you to as a reference, right?
Yes, doktor.
Plus with the wall to column cast sekali dengan wall ke? Oh, tadi ada soalan Sorry, I tak baca. Tadi I punya komputer. Ni. Flush with the water and column cast, tak cast sekali maksudnya dia macam mana maksudnya? Dia tak terkeluar. Dia punya wall kalau you tengok rumah orang, column dengan wall dari luar you tak nampak. Column tu terkeluar kan? Dia mesti satu straight line, maksudnya dia flush.
Dia flash maksudnya
Semua
dia
saja. Kalau
casting macam mana? Casting kolom dulu ke sekali semua?
casting sama lah tapi dia punya location. Kalau you guna software, Esteem let's say you belajar kan, you boleh flash column in, maksudnya you move location dia. Kalau let's say you punya wall hanya 150 kan thickness dia, tapi column-nya 200. So dekat luar tu, yang properties tu kan, dia punya 200 dengan 150 punya exterior adalah sama. Tapi dekat dalam rumah dia terkeluar yang 50 mm tu. Sebab column 200 and then wall tu 150.
Oh.
So dalam rumah terkeluar tak apa, kat luar rumah jangan terkeluar.
Okay, faham.
Kalau you punya rumah keliling, column terkeluar kan pelik. Tak cantik lah kan? Maksudnya dia punya flush macam tu. Maksudnya you boleh masukkan dia ke dalam properties tu, jangan terkeluar.
Oh, okay.
Maksudnya dia flush macam tu lah. Yang lain faham tak? Sebab kalau let's say rumah biasa, rumah double story, rumah terrace lah, you tak boleh nak ambil tempat orang kan. Mesti you dekat between you in your limitation of your properties lah. Properties kan tanah dia straight line. Jadi you tak boleh terkeluar terkena orang punya tanah. Macam tu lah. Ini saya akan bagilah. Saya belum bagi. Saya tak boleh bagi yang answer scheme final tu. Tak boleh. Tapi saya akan bagi ni dulu. Sebab itu nanti I nak bagi you practice dulu. Kalau I bagi you jawapan macam mana you nak practice.
Oh, betul. Okay.
Okay, satu persatu. Tapi ini I akan bagi dululah nanti. Sebab you have to do it. For the example yang I bagi tutorial itu test 1 punya soalan. Oh dah Dah kan? Kita habiskan ni and then you do your tutorial, kita habiskan sebelum jam 12 lah. You are happy, I'm happy, right? So let me open this to wider slide. Contoh mate. Tak payah, I buka dulu. Okay? And then ini height. Height screen print review. Answer scheme, where is my answer scheme? Okay, wait, let me stand by it. I nak keluarkan color. Pen. I want to use a yellow pen. Okay, so you can see this is the. Semua dah ada? Ada yang hilang belum?
Ada je.
Ada Kita habiskan
Ada,
cepat
ada.
kita. Nanti you dah tak boleh absorb lagi kalau lepas 2 jam. Okay, so ini architecture drawing. Okay, so this is architecture drawing. Architecture drawing, you nampak lah dia ada dimension. Normally kalau kita buat akan in millimeter. Okay, so you need to draw by hand and then you agak-agak lah you draw, no need to be really skillful. Tapi kalau you ada yang boleh tekap lagi senang, you tekap je atas je. So normally if you print out and then you do it, it's better lah. So, okay, ini A1, A1B, B1C. So A1B, B1C, you have this lah. And then 1 to 5, you have 1 to 5. So you draw also need to have something like this. So easier for us to refer what is the beam and this and so on. So firstly, you look at the beam. Okay, so this is a bed. You look at this one first. We explain this. So this is a first floor, bukan ground floor. That's why you tak ada ground floor punya tempat pintu masuk. Dia terus TV tangga naik. Okay, first floor plan, tangga, your staircase, you climbing up. Okay, bedroom 3, 4, and 5. And then you have toilet area, bathroom 4. Okay, bathroom 4 for bedroom 3, bathroom 5 for bedroom 4, and the bathroom 5 for bedroom 5. And then this is TV area and balcony. Balcony, they have a curved slab. So what you have to do now is you need to plan the beam. You can see that, huh? Yeah?
Doktor, your
Tak dengar,
mouse,
dengar tak?
no, your mouse do not function properly. Dia macam sekat-sekat lah macam tu. Mouse.
Tak ada.
Bukan. Dia macam tak.
Cursor.
Yes.
Laser ni tak betul.
Sekat.
It doesn't work.
Dia
It doesn't function properly.
Dia tercekik-cekik macam tu.
Dia macam
Okay, so
sekat sikit.
kejap. I tukar pen.
Better.
Tapi I tak nampak pen I masalahnya. Tukar color. Kejap. Red color. I can see the pen. Can you see my pen?
Can.
Can So now you firstly you look at this, you plan the beam allocations first. Okay? So normally ini you nampak ini, then from 5A to C, okay? 5A to C, then you can see this is one beam lah, one beam, okay? And then 4 to, okay, I go one by one here. 5A to C, you will see here, you will have to have a beam lah. And then 4 to C, 4A to C, okay, 4A to C, here you need to have one beam. Even though here you can see that this is not drawing like a beam, but then actually it has. Okay, you cannot have a beam. Some of the students always makes a mistake. Here they leave it blank, no beam. Here they leave it blank, no beam. Okay, but actually you have to connect. We didn't see the beam from the architecture drawing because this is architecture drawing. It is not structural drawing, so it will not show you what is the beam that stay underneath. Dia dah flush into the slab. On roof, do you imagine you pergi first floor, you go to the first floor. The beam is already flush, same level with the slab, right? You will not like the slab, the beam suddenly come from the floor. It will make you fall. It is not nice. So the slab, even though it will flash into the slab together, and then from the ground floor, when you look at the ceiling, if not being covered, then you can see some of the column. I believe you can see that normally in the school buildings, in even in a terrace house is normal. If the building is not being covered by the ceiling. Can you imagine that? Biasa nampak kan slab ada column dekat atas kalau ceiling. Normally at the first ground floor you can see the first floor with the the beam, right? Can everyone imagine that? Can, right?
Boleh Dr.
Adi
nampak.
Rama,
Ada.
you with me, Adi Rama? Biasa kan kalau you rumah yang tak ada cover, like if your house is not being covered by the ceiling, you can see the beam. Okay, so here you have a beam. Normally, ingat this one normally student make mistake for the beam. Okay, for 3A to C. Here you know beam. Okay, here you can design the beam. Here, of course, here, even though here not showing here, showing the door, but the beam is not only stuck at here. It will connect to here. Okay, if you're not sure you want to put the beam here or not, you can decide later. But for the main beam, you need to put it first. For this size is 1830 means is 1.8 meter. 1.83 meter, 1.83 meter. Okay. So you can do the beam until here first, and then if you can decide later you want to connect or not. Okay, you can connect until here also can. Okay, but that is not until this area. This area is considered small. And this consideration, like the design, how you're going to do it is normally sometimes based on your experience also. Okay, and then from 3 to C, here, even though it's not showing you anything here, but you need to connect the beam. The beam cannot start halfway here. Remember, the load from the beam will distribute to the nearest column. If your beam is only stuck at here, then all the load from the slab is not going to beam. The loading from the slab needs to distribute to the beam. Okay, to the beam. So it was surrounded by the beam. So if you here you didn't put the beam, so the load is going to weigh. If you didn't put the beam here, means the slab is continue with this slab. So it will making it more troublesome. So easiest is make our slab to rectangular shape or square shape. Don't make it like the L and then this and so on. So this beam must be continued. Okay, so here also continue a slab, a beam. Okay, because here there is a column and there is a beam here, so you continue under here. Okay, and then here, okay, here, number 4 here nothing, right? So you no need to put slab here, the beam here, right? Here leave it at the slab, and then here, because at the bathroom here you have a secondary beam. Here you have a beam, so you can also break it because you can see that this slab is wide. You have 1.52 meter plus 3.35 meter plus this one how much? This one here how much? Oh, this drawing is missing at here. I couldn't see the dimension here. Okay, so you can see that this slab is very big. When you see the slab is big, you can break it to 2. So the load is being distributed to the beam nearby. It will not have the 2 big deflections. If your span of the slab is too big, it will cause a deflection, like just now the slide explained before. That's why this TV area, we make a beam here. And then here is a beam here. So we can make it the slab smaller size, smaller span, and distribute to the beam. So to reduce the deflections. Okay. So you make it to FS1, FS3, FS4. Okay. So you can see that this one here, balcony, of course, you have door to go inside, right? You have the glass door and so on. So that's why here it's not connected. But when you do the beam also, again, you need to connect it. That's why you have the connected one. Okay? So this is it. And then you can see the vertical one. Now A5-2. Okay, of course, here you have a beam, continuous. And then at here this is a single slab, so the beam is start from the number 4 to number 3. Here, so that's why you have a beam here. Okay, so this area is just small area, and size is very, very small, you can see the size is just, okay, you need to deduct the value. Sometimes if you want to do the calculations, okay, you can calculate. Okay, so this area is small. If you no need to break it like too many slabs, if you want to break it, also no problems. When you are the engineer, you do it as long as it's safe, nothing wrong at all. But then it's also you need to consider the the cost. Okay, you can cut down the material cost and so on. No need so much. Okay, so here this area you combine as one slab, two-way slab, and here you combine as you split it to slab 1 and slab 2 because here there is a beam until here. Okay, if you want to connect this column, no problem. And now this slab, and you want to connect, sorry, you want to make it like a beam right here, nothing wrong also, can also. Okay, no problems because you are the engineer. So here you can see here also you have a beam here, but it's only until here because this slab we already covered. The beams not always need to be from the edge to the edge, not necessarily from this edge to the edge at the middle. You need to base on the suitability. Okay, so basically beam is how you determine like this lah. Oh, the door, even though they put it like architecture drawing, there is no connection at here, but you need to connect it when you draw it. That's why this is all connected. Let me remove all the marks. I feel annoying with too much of the mark now. Discard. Okay, let me show it once again. Now it's clean. Okay, now it's clean again, so I will continue. So beam you nampak you have to connect it. You see, right? So you can, I will give you this one so you can go back and then you self-study and look at it how it been done. So when you do the tutorial, you can base on this one. Okay? So this one, how to convert the beam to estimate the beam allocation, this one is based on your experience. And if you design using the software, if your slab, normally when you run, when errors mention the slab span is too wide, the deflection too big, so we will break it, the slab to smaller slab with additional beam. Like this, we break it to three slab because it will cause a huge deflection. So we break it to 3 steps instead of only 1. Okay. So beam mark, also you need to mark the beam. Okay, the dash line, I already explained suspended slab with the beam, then you use the dash line. Because outside no more slab, right? It's the outer one, that's why it's using the solid line. And then the staircase area, there is no step, that's why it's solid line. You can see this is solid line. Okay, solid line. Because means that it is not being connected. But here is dash line, means that the staircase is connected. Okay, to that area, because staircase is connect to this area, right? So that's why here is dash line. And you can see that this is the toilet, the bathroom. Bathroom you have drop. It doesn't mean that it is non-suspended, but then the drop, the slab is lower than the beam. It is not same level as the beam, so that's why they have a drop here. Okay, you can see that they mentioned drop 50. Okay, here also you have the, but it's not clear the drop. Okay, drop 50. Okay, so that's why that is the solid line. You can see this is solid line, right? Okay, so the other area is using dash line. Okay, means it's suspended and same level. For toilet is using the solid line because it has been the drop. Okay, so this is the line that you need to have, and then the beam line type. Okay, the beam line type. The beam line type is a dash line, beam marking, allocation, and marking. So normally you need to do the marking. If the beam mark here is also mentioned the marking for the number. So you can see that they arrange the beam number. One. Let me change color. Wait. Green color. Okay, 1, 2, 3, which is number 4. Okay, I cannot see. Okay, for it will go from the bottom to the top, and then from the left, 8, 9, 10, and so on to the right. So when you level the beam mark, you need to level from the bottom to the top. From the bottom to the top for the horizontal beams. Let's say we are horizontal view here, horizontal. And then for the beam from the left to the right. Why you have to do that? Why you have to do that? Make it arrange like that. You cannot simply put beam 1 here, beam 2, beam 3 here. Make it standardized so when you are the engineer that you have to refer back so you will know easier how to look at how you check the beam. So you from the top and bottom to the top, you find the beams according to the numbers from the left to the right. So when you do for your project also you have to do like that lah. Okay. So from the, I repeat from the top and from the bottom to the top, from the left to the right. And then the beam lifetime needs to correct. And slab location, slab mark and thickness. One mark. So you need to mark the slab also. FS1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one, if supposedly is 11, 12. Okay. But they have, I think this is type error. Okay. So you can see also from the left to the right, from the bottom and from the bottom. Okay, left, bottom the most, and then left, right to the top. You need to mark it, and then the thickness here is, if you mention it here, okay. If you not yet mention, also okay, no problems. But if you already being inside, you need to mark the slab thickness lah. Here got the mark because it's based on this one.
Basically kita kena lukis balik kan. Sketch
you have to lukis balik.
Sketch ke kena
sketch saja, tak ada.
Kena apa ukuran.
Kalau dalam test sketch saja. Tak agak-agak, but you need to have this mark lah. You need to mark this. You sketch not necessary to be exactly the same, but you need to put the A1, B, B1, C with the dimension.
Yes, I know.
This one needed.
Yeah, macam dotted line,
but
dash
not
line, solid line, everything.
Itu agak-agak. Solid line and dash line is agak-agak, yeah. As long as you can differentiate what is solid line and dash line.
Oh.
And this symbol for the slab, you need to mark the symbol lah. Is one way or two way.
Okay.
To calculate one way, two way is easy. Ly over Lx. Ly.
Bigger.
Li is the bigger one. So let's say for this slab, for example, for this slab, you can see that this is the longer one, right? This is the longer one, right? 3965. So this is Ly. So this is 3050, right? So this is Lx. The longer one is the Ly, the shorter one is the Lx. So you divide. If less than 2 is single. If greater than 2 means is double. Is less than 2 is double. Is greater than 2 is single. So you can see example, I think is from this one. Okay, you can see that this one supposedly the value is, I cannot remember, but it's no. Here is all two way. The other one way. Here is all two way. It's marked at two way. Okay, when the ratio of Ly over Lx is over than 2, then is single. You will learn it more next. Like if you have drop, then you need to write it like draw 50 lah. Here have a drop, but then the drawing is too small, you cannot see. Okay, then drop 50, then you can mention the drop 50 here. Okay, so let me clear it first. It's very messy now. Let me clear the. Okay, So after you decide the slab, then we go for the column. Column allocation and column marks. Also 1 mark, 1 mark. Staircase, mark 1 mark. Staircase is easy. You can see that you mark the staircase. It's going to this is the staircase. You draw like this also can already. Okay, you draw the staircase. Like you put the dash line, the staircase, STR. Okay, and then the column. So the column, you need to have the column mark and allocation. So the column mark here, let me go to this. Slideshow, wider look. Okay, so at the architecture drawing, it will not showing you this one. If this book, why I accidentally click the end slide. Wait. Let me show you my pen. I use the blue. Okay, so at the architecture drawing, it will not show you the column type or column locations. Okay, it will show you a little bit, but you can decide the column, how does it look like, and so on. Okay, so you can see that here you have a column, the black one, here the dash are the, what does it mean? The H. This one means the H, you color it to dark color. The black color like this is H1 means on it, and the upper floor still have, means that this is until roof you have the column. After this, supposedly it's roof floor. Okay, so this one, as I mentioned, the column normally is at the corner or either at the intersections. So you need to decide where is your column. So normally you can start from the corner first. So you will have one here, okay, one here, here. So the main one, all you need to have. So here. So here is just very small area. You can make it just this curve, the curved beam as secondary beam. So here will become point load and beam. So this will transfer the load to this FB1, and then here will react as point load. So when you calculate the load, you will have uniform distributed load from the slab and also the point load from the curved beam. Okay, so here is just toilet. That's why you have no column, because the column here and here is too near. Okay, you want to put a column here, no problem, but it's like a waste lah. So you design the column here, okay, and then another column like here, here, and here. Okay, distance normally like around 3 meters and above lah. Okay, you can see that. And then next, you need to decide the column inside. So here you can see that here is like a big area because, okay, because you want to make it like a square. And then the load is distributed here only, and here there is no column here. Then it is easier to bend because here you have a long continuous beam. So the intersections, you need a column. So here you will have a column. But then at the bathroom, as I said, bathroom normally the load is very small, and then normally the beam size review is very small. For the main beam, okay, beam size for the toilet normally is smaller than the main beam lah. Okay, so here no column, all here will become point load, okay, point load, and here is point load, here is point load, here is all point load, because the area is, they are too close, no need. Okay, so here also no column. Okay, not nice. Suddenly your room, suddenly there is a wall and then the column appear. Not nice, right? Okay, so here you can see that here also you need to put a column because it's like at the middle. It will distribute the load, okay, and then it will distribute the load from around here and around here to these 3 columns. So that's it for all your column for this floor. Okay. So any questions on how to put all these? Basically, you need to put all these items. Okay. All these are the compulsory things in your your structural drawing. Let me show you once again. I will give you this one for you to refer to. So this is the mark you give. Normal, this is the answer scheme from the final last time. So allocation 1 mark, beam mark, 1 mark, line type 1 mark, allocation 1 mark, slab 1 mark, column allocation 1 mark. To the top, but then this one they put the same type C1 here means they are having the same type of column. Okay, but if you don't put the column number, it's okay. Normally the build need to put the number. The column will be normally the column will be the same type. So that's why they put the same column type, means the same size. The design will be only one. Okay, and then the staircase mark here. So this one I will not give you, but then this architecture drawing I will give you. I already asked you to write this, right? If not, then you can print. You can find it in the video in this teaching lah. Later I will upload in the YouTube and then share the link to the classroom. So let me open the. I already prepared a tutorial for you guys in the Google Classroom. Tutorial chapter 2. So what you have to do is you need to yes.
Yang depan pintu tu apa? Tangga.
Yang ni.
Dia dua kotak tu.
Ini.
Dekat kitchen. Dekat kitchen kan ada pintu kan? Depan pintu.
Apa ni?
Depan pintu.
Depan pintu dia apa
Dua kotak tu.
Yang saya buat tu. Itu tak ada apa-apa. Let me apa tu? Wait, I want to open the answer but I don't want to let you guys see. Oh, dia ada box juga tapi dalam I don't want to show answer. Apa tu Tangga dia. Lah.
Tapi tangga, dua kotak tangga je.
Ini sangat kitchen, bathroom, kan. Kat mana? Propose the ground floor structural layout plan for the house indicated by the structural elements. This is ground floor. You can ignore that one first. I think it's just the tangga pergi kaki 5 tu panggil apa the Malay language.
5 kaki 5.
Small one lah.
Small one lah. Okay.
The small one. 1, 2, 3 no more. The answer is somewhere there.
Okay.
You practice first. Don't worry. I will not. You answer correctly or incorrect. No marks. I will give you the answer later, but not now.
You don't angry lah.
Outside dia tak perlu. No. For this is you get to practice tutorial one. I will not deduct your mark. This is for you to practice. You just need to design for this. For outside no need.
Okay.
Outside no need. You draw this one. You draw the bit for this one. Kitchen, bathroom, bedroom, dining area, bedroom, living area, bathroom 1, master room. You draw this. The structural drawing. Okay. This is question from last semester, test 1. Normally test 1 you have to do something like this, and also the final, because this is the kickstart step to convert the architecture drawing to structural drawing. So you practice it first and then submit. Then next week I will show you the answer. Then now
Doctor, the outside one no need, right?
Outside one no need. Dia tak ada apa. Outside one no need This one no need. Because it's not first floor. Kalau first floor need lah. Now no need. Ini just dia punya frame saja. The building of it. You just design here. This area. So any other question for today class? You want this? I know. I will give it to you later. I will upload in the Google Classroom. Any other questions?
No, Doctor.
Ada seorang tak hadir tadi, siapa nama? If you have question, you can also ask in the Telegram next time, in the one. And then anyone just now not being recorded for the attendance, siapa nama dia? I think she is she is not around lah. It's okay because it's only 50. There's one not here. So class is only until here today. So next week no class, but I already prepared a take home quiz. Take home quiz is also still chapter 2. You can see it, but I don't want to give you yet. Take home quiz is, you can see what I share now, right?
Yeah.
I already set the take home quiz, but next week then it will appear. Okay, you can answer, you can print it out, answer, and then send it. Okay, so this is it again, but this one you need to consider this area. Outside also you need to draw. You need also pass your question, huh? But not this week, next week. You want this week? No lah, this one
No
for
lah.
you when you are fasting. Then you need to concentrate.
Yeah, okay.
No lah, not this week, next week. You do one first. Okay, next week. Next week no class, but then during that holiday I will upload that. You don't need to open that. So later no lecture, no student is complaining me doctor having class during the public holiday.
Oh no lah.
Okay, you can do it. Then the due date is Thursday, next Thursday. Next Thursday. Okay, so see you guys the week after for chapter 3. Any other questions?
No,
No
Doctor.
questions? Okay, bye. You can leave the class. I will end the class today also. Let me stop recording.